Okay, so in this question, we are given a point and we're asked to decide whether it's inside or outside of a circle. And we're given this equation here. So underneath, I've wrote the equation that we normally use for a circle, so you should be quite aware of this. So you've got x plus a squared plus y plus b squared is equal to c squared. And just as a quick recap, we're going to go through what the centre would be and what the radius would be for this sort of question. So when we're looking at the centre, it's important to note that we use this A part and this B part. Okay, and so because it's inside the brackets, we're going to change the sign around. So in this case, my centre would be minus A and minus B. Brilliant. So let's have a look at the radius now. So our radius is determined by this C part. So our radius is given as C. So just take a little note here if you haven't already, that we are given it's equal to C squared. So in order to find the C, you're going to have to square root whatever it's equal to. Brilliant. So how does this relate to our question? So we're given x squared plus y squared equals to 30. Now, this doesn't look very similar to the normal format that we're used to, but we can write it in this format. So are you happy for me to write x plus 0 squared, which is the same as x squared, plus y plus 0 squared is equal to 30? Which means in this case, my centre is going to be 0, 0. And my radius will be the square root of 30, which if you type on our calculator, we get 5.47. Actually, we'll do that to 2 decimal places, 5.48. So now let's have a look at how to draw this then. So if I just draw a quick circle on the screen, and this is obviously my centre, the radius for each one is going to be 5.48. So you can just roughly write that on. Okay, so I haven't wrote these as coordinates. It might be useful to write as coordinates, but I'm just doing it so we've got plenty of time. Okay, so we're now asked to determine whether the point 5, 2 lies inside this circle. So just for convenience wise, let's say it does. Okay, so let me say, okay, this is my 5, 2 coordinate. But let's have a think now. In order to determine whether this is actually inside the circle or not, we're going to have to use Pythagoras. Now, I bet you're thinking, why do I use Pythagoras? Okay, so the reason that we use Pythagoras here is because if my longest side, so this hypotenuse, is less than 5.48, then we know it's inside the circle. But if it's bigger than 5.48, so the radius, then we know it's outside the circle. So let's write on what we know. So considering this point is 5, 2, we know it's 5 along the x-axis and 2 along the y-axis. And we are wanting to find out this value here. So using my Pythagoras, hopefully we're aware of the Pythagoras theorem, which is a squared plus b squared plus is equal to c squared, And c is always my longest side. And remember that a and b don't matter. If you're stuck at this, have a look at my Pythagoras section on the website. So here we'd have 5 squared plus 2 squared is equal to x squared, which is 25 plus 4, which is equal to x squared, which is 29 is equal to x squared. So if we want to find the value of x, our last step is to square root this. So the square root of 29 is going to give me 5.38. Brilliant. So because this value of x here is less than 5.48, and it's actually 5.38, we know that this point will be inside the circle because it's less than the radius. Brilliant. Well done.